Well, friends, now I am going to present my research work related to the development of the glass nutrient fertilizers for agriculture purpose. If we see in last 2 and 3 decades, our farmers had been used a lot of chemical fertilizer, insecticides, pesticides for enhancing the production. As a result, our soil and land is going to be, or you can say, turning towards non-fertile nature. So, considering this aspect, we got two objectives or motives for doing this research. Our main objective is to develop glass compositions for the plant nutrient, and second important aspect is to develop some specific compositions for removal of this non-fertility which is being developed in most of the parts of the India. Perhaps we all are aware that our soil is also having a definite chemical composition, and we can provide a number of nutrient elements like your nitrogen, phosphorus, potassium, sodium, magnesium, calcium, sulfur, boron, cobalt, copper, iron, manganese, zinc, molybdenum and vanadium through the glass matrix. So if we see our first objective of the study, we can provide the same nutrition as chemical fertilizer through the glass matrix. For this, we have to develop various types of glass compositions. Now the question is this: we are preparing this glass nutrient fertilizer over chemical fertilizer. So what are the advantages of using glass nutrient fertilizers over chemical fertilizers? So we see one or two important aspects. First is that our glass compositions are more economical than chemical fertilizers. If we see the economic aspect, we have to apply once, or you can say 1 year, this glass nutrient fertilizer to the agriculture field. It will work up to the farmer field for more than 1 or 2 years. Every year we should not need to apply in the farmer's field. So in this way, in 4 years, if we are applying the fertilizer in one time, means we are going to reduce the total cost 1 by 4 times. Second aspect, if we prepare these glass compositions as our pilot project, we can collect the soda lime glass from Kawadi, you know the cost of that glass is only 50 paise kg. So we add our micronutrients, required micronutrients in the form of inorganic salts during the melting of that soda lime glass. In this way, the glass prepared is very cost effective. So in this way also we are also reducing the preparation cost of the glass. The second aspect is our glass compositions are always non-toxic to the agriculture field. If we see the chemistry of these glass, so we must have an idea about the hydrolysis phenomena and solubility of the glasses. So here our glass compositions will work as a slow release of the micronutrients from the glass matrix or glass network and work for a number of years in the farmer fields. Now I am going to show my steps of the research. How can we prepare these glasses in the laboratory? So first of all, we take all the required compositions and mix it in the agate mortar crystal, and this is our melting furnace, which is having a maximum range of 1200 degrees centigrade. Now these are the crucibles in which we put our mixed composition. So you can see these are the alumina crucibles in which we have melted the compositions and put in the furnace for the required temperature of the furnace. After getting melts, we pour these glasses and take a shape like this. So these are our melted glasses in the watch glasses, and in beakers we have the powder form of the same glasses after getting a ball milling for 15 to 30 minutes. Now in the next step, or you can say sidewise, we are doing the leachability experiments just to check the slow release of the micronutrients from the glass matrix. So we know the crop cycle. Most of the crops or most of the vegetables are taken 2 or 3 months for their full growth. So for the 2 months we are doing this, and for testing the agriculture aspects of these micronutrients we have developed a small segment of the agriculture field in our department, where we have applied the ladyfinger seeding and bean seeding at this moment, and applied this glass powder to the field just to check their impact on the vegetables. Okay, so you know, finally the micronutrients which are essential for the physiological functioning of the plants throughout their life cycle. So we are trying to develop a better substitution of the chemical fertilizer in this way, and to develop specific glass nutrients for the removal of the non-fertility is being developed in the farmer's field. Lastly, I am thankful to Design and Innovation Center of IIT BHU for providing me financial assistance for doing this research work. Thank you very much.